Based on this surface geology map, we see that all of the outcrops to be visited are of Upper Cruse age. The crest of the southern anticline is interpreted to trend west to east. However, dips measured on the coast and on the interpreted crest all show northerly dips. So either the crest lies to the south or there is some kind of system that creates a second fold which we do not see in the maps. In this structural cross-section from Kugler 1959, it has been interpreted that the mud flows rising upward to the surface does so along a reverse fault. The Lower Cruse and Lengua formations were proposed as the source of the mud. However, abundant topographic map Herrera class suggests in a red box the outcrops to be visited. We will start in the west and walk eastwards back towards Angler Point.
We are still in the area affected by the mud flow. You can see failure plains above us there, but what we're seeing are parallel bedded, parallel laminated clay stones, which obviously have been incorporated into the slump. Take a closer look over here to see disturbed bedding, parallel laminations. You see changes in the thickness of the beds. You see parallel bedded sands with lignites in them. And here we see one of the slip planes within the slide itself. We have now rounded Palo Point and we're passing the 2018 slump, and we're now walking east along Palo Seco Bay. First headland is Angler Point, and the second headland in the distance, that is Roja Point near Quinam. Here we are at the first in-place sandstone outcrop. Beds are apparently dipping to the northeast. It's predominantly sandstone. We also noticed that there are a number of small vertical falls with throws about 6 or 7 inches. Our second sand outcrop. In this case here we see the dip is slightly different and it's more northwards. Beds are parallel bedded and we see parallel laminations, and the black material tends to be carbonaceous material. We see that there are quite a number of normal faults affecting this outcrop. Here we see there's significant disruption of the outcrop by faulting. So here we are the second sand outcrop. We notice that there's significant disruption of the bed by faulting. You see normal faults, and on this normal fault we're actually seeing drag or deformation of the sediments along the fault plane. We're still at the same outcrop, and we're seeing more parallel bedded and parallel laminated sands. In this case here, we're looking at a normal fall that is about 3 feet of displacement. Third outcrop of sand. See, it is affected by small fractures and a whole bunch of small normal faults. Dip in this case here is to the northwest. We are seeing sands at the basal section. We have calcite cemented sands that appear to show sigmoidal bundles. As we come up into the sand here, we start seeing soft sediment deformation in it. We see small flame structures. We see that the tip of the flame is pointing to the west, which suggests that that was the direction in which the sediment slumped. So there's a zone of extensive slumping within this basal sand. You see there's a small zone of fractures above with what appears to be ripples. Another small fault overlain by evenly bedded sands with ripples, a thin clay stone, and then more sands above. Those vertical stains represent water migrating along modern fractures and not rooted zones. Here we see what appear to be clay drip ripples within the unit. We're also seeing small sin depositional faults within this sand outcrop here. Here are some big rounded boulders. We're now at a large in-place outcrop. You see it's overlain by clay stone. There is a floating block of sand above, another floating block, a clay stone, and then we come to our first bed, which we see significant amount of slumping and flame structures. In this case here, the flames are pointing to the east, which suggests that is the direction in which the sediments moved. That bed goes towards the bottom, becomes parallel bedded. We see this sand bed is underlain by a clay stone. Then we see some large floating blocks of sand. Here we see sands exhibiting slumping, ball and pillow, and flame structures. There we see some ripple sands above. And these sands grade upwards into clay stones. As you can see at this point here. We're walking along again, we start to see some sands overlain by clays. These are some fairly substantial blocks, probably at least 30 feet high. And we can see they have been involved in some kind of slump because they're almost completely surrounded by clays. These are the clays here. Which we are seeing forms part of a very significant slope failure. The edge of this outcrop has clearly been cut off by a slump. We've come back to parallel bedded sands and clays. Again, we're seeing intense fracturing in places. We see some small normal faults. see lignites floating and at the base of beds. These rocks dip at roughly 60 degrees to the northwest. See that there are abundant fractures in the outcrop. We're saying fractures because we're not seeing any of the beds displaced. Here we're seeing some deformed clay stones which underlie the sands. There's Angler Point in the background. There's an outcrop here in Palo Seco Bay that has been described by a number of people, by Vincent in 2012 and by Chen in 2015, or it could be Peng in 2016. Here we see well-bedded Cruse sands with thin interbedded clay stones. Most of the beds are parallel bedded and appear to be parallel laminated. It's clearly obvious that the clay stones are extremely unstable and prone to collapsing. Here we see a close-up. We're seeing some sigmoidal climbing ripples.
Thanks for watching this video.
Look, we see these sands are fairly massive and they grade fairly quickly into overlying clay stones. So fairly structureless looking clays.